Thank you very much, Mark.
Great stuff. I can see your screen, so I'm going to go on mute.
Excellent. Hi, everybody. Welcome to my session, Introduction to Azure SQL Database for the DBA. Now, in all honesty, it is for everybody, but there are a couple of slides that would definitely pique the interest of the DBA. I'm going to talk about things such as extended events and CHECKDB, so that will definitely get your classic DBA excited. Mark's already done a great introduction about myself, so I'm going to skip over this, but I will say, please note my email address at the bottom. If you've got any questions regarding this presentation or anything else across the data platform, please do drop me an email. I usually reply within 24 hours. So I have 5 key objectives today. First, I'll start off with an introduction to Azure SQL Database. I'm going to take a step back and just talk about cloud computing as a whole and what Microsoft Azure is doing to SQL Server professionals. Once I've laid down the foundation, I'm going to dip into service tiers and compute sizes, because it can get quite confusing, when you're trying to think, should you go DTU, should you use vCores and so forth. And then the important question is, how do you size your on-premises SQL servers up into Azure? I will show you the technique that I use. So I think you'll find that very useful. And then 2, which I think are the most important topics, security, and then performance and monitoring. Just to let you know, the security is not just about the features available to help you build a secure, stable database infrastructure, but it's also other things which you'll need to consider, like IP addresses and vNext and so forth. So first of all, why talk about Azure SQL Database? Well, being as a classic infrastructure DBA, I've noticed this move to cloud computing, and I'm fortunate enough to have that move into Microsoft Azure. And if you are in a similar situation, you would understand that at the core of this will be Azure SQL Database. Yes, of course, there's many other sorts of flavors of Azure SQL Database that I'll get to, but this is what a lot of companies will be moving towards. So what I would say is that yes, there is a change, things are going to be slightly different, but I believe one should embrace this change because it's a beautiful thing. Just taking a step back for a minute, obviously we're going to be building all our solutions based in Microsoft Azure. I just want to show this slide because it shows you the global infrastructure that Microsoft now have. They obviously invest billions of dollars into their infrastructure, and that kind of manifests out into the fact that new regions are coming up every year at least. And really you should be building solutions based to where you are geographically located. For example, I'm based in the UK, and 9 times out of 10, I'm going to be building these database solutions in UK South, or its paired data center being UK West. Obviously, this will vary to where you are. So let's get to it. What is Azure SQL Database? Quite simply, it is Microsoft's intelligent, fully managed relational cloud database as a service. You'll hear that term, database as a service. Some call it DBAS, that's a shortened way, but really it's known as platform as a service offering. And Microsoft had this strategy, a cloud-first strategy, and this does have implications in a positive way to SQL Server professionals. Because by this, what I mean is all the new features actually get pushed to the cloud first before you see it on an on-premises product. Just to give you an example of something like automatic tuning, which I believe came live in SQL Server 2017, but I was using that before in Azure, so you can kind of see their strategy there. And I really like this diagram because it will show you now, as database professionals, the different types of SQL servers out there. And honestly, you would probably be looking after all types, and I do. Classically, we started off from physical, and then we moved into the idea of virtualization, whether that was VMware or Hyper-V, sidestep into containers as well. And the blue boxes on this diagram shows the move to cloud computing. Infrastructure as a service is literally just SQL Server virtual machines, but we will be concentrating on the top box there, Azure SQL Database Platform as a Service. So there's this term out there online which come about from Microsoft called Azure SQL, the Azure SQL family. And it's very similar to the previous slide. You've got the infrastructure service on the left, the virtual machines, then you've got the platform of the service on the right is what we will be talking about. But you've also got Azure SQL Managed Instance, which is a game changer for many. It's a brilliant way of just lifting and shifting instance level workloads up to the cloud, even supports native backups. Just going to show you the complete picture there of which route you can take. You can have all or any of them. But again, we'll be concentrating on the platform as a service. So once you've decided that you want to go to Azure SQL Database, be aware that there's many types. First one is what I call normal mode. Well, it's not really called normal mode, but it's just what I call it. This is the idea of just having provisioned compute. And this is usually based off a DTU model or a vCore model. You've got something called Azure SQL Database Serverless. With this, you've got the idea of pausing and resuming compute based on activity. And I've got a dedicated slide on this because I think it's quite important. If you've got architectures that need to support anywhere up to 100 terabytes, well, that's now possible with hyperscale. And this has totally different architecture under the covers. And a newish one is called SQL Edge. This is more geared and optimized around IoT streaming architectures. Just think of it as it could do everything that analysis, the Azure streaming analytics can do, but then some. So one of the most common models out there is the DTU model. DTU stands for Database Transaction Unit, and this literally is just a blended relative power of measure of power for your database. It's just a measure of CPU, memory, read-write rates. Typically, we've got 3 to choose from. These are called service tiers. You've got basic, standard, and premium. And your key decision will be, where does my workload sit within one of these tiers? So I just want to talk about the relationship it has with compute sizes. So within each tier, you've got a compute size. So if you study this screenshot at the top first, you see that I have selected the standard tier and I've scaled all the way up to 3,000 DTUs. This means I am at its 12th compute size. And this is true also for premium, which you can see at the bottom. Here, I've selected the P15 compute size. And obviously, that depends on how powerful you need your database. But this screen is a summary, and the biggest takeaway to take from here is, in production, your decision will probably be around standard and premium. But what I will say is the biggest difference is the I/O. If your application needs high I/O throughput and or low levels of I/O latency, you would definitely need the premium tier. And obviously it does come down to features as well in some situations. For example, as you can see on the screen, if you're building a solution that just relies on in-memory OLTP, well, you've got no choice here but to go down the premium route. Now you're probably sitting there thinking, well, that's great. I still don't understand what an S2 is, an S3 and so forth. Well, there's another model out there called the vCore model. And this has a totally different approach to sizing your database. And honestly, it's actually a bit easier to understand because the concept of having a 4 vCore model, you can kind of relate that to an on-premises server. And in the vCore model, you've got the general purpose, business critical, and hyperscale. We've mentioned hyperscale before, where you want to get to those many terabyte scale. But again, the difference between general purpose and business critical is going to be geared down towards the I/O performance from what I've seen. If you need high I/O throughput and low latency, again, it's going to be business critical. But obviously with other things as well, which you probably need to research into, you'll have, for example, you'll have access to more read replicas with business critical. These are based on, generally based on Broadwell and Skylake processors. For the provision compute, you can see you can get up to a maximum 80 vCores. And if you opt to go with the serverless edition, then you can scale up to 16 vCores. which is now actually. So I just want to study this picture for a minute. Here, the picture speaks 1,000 words. Now, this is Azure SQL Database Serverless. You can see from this diagram, there are two main parameters here that of main interest. These are called the min vCore and the max vCore. As you can see from this diagram, this workload bursts between 1 vCore and 4 vCore, okay? And then when it gets to an inactive period, which is a period that you define, it will go into a pause state. And that's where you actually save money. And then you'll notice that it will spike up again. This is based on the fact that you've initiated some sort of login or a process or a system process that you've initiated. You will notice that the status of this type of database will go into a resuming state back to an online state. And just one thing you should be taking away here is the impact it has on memory as well. The amount of memory assigned to this database is dictated by your min vCore, your max vCore. At the time I developed this presentation was a factor of 3. So that means for this specific situation that this database had a max memory of 12 gig of RAM, being 4 times 3, and obviously the minimum was 3. So that's something to bear in mind as well. You'll probably want to know about compatibility levels as well. So as of January 2020, when I created databases then, I noticed the compatibility level for the databases was 150, which meant 2019. I believe this was mid to late January, but I wanted to put this slide in here because I wanted to show you that it's still flexible. If you choose to go all the way back to 100 compatibility level, that's fine. You would do so as normal with the alter command. Again, just showing you that there is some flexibility with Azure SQL Database. Big question, how do you size your on-premises workload up into the cloud? Traditionally, many people have probably used something called the DTU calculator, and I'm sure there's many other techniques out there, but I've always relied on this one, has a very good starting point, PowerShell. Now, these PowerShell scripts you can get once you install a tool called the Data Migration Assistant, okay? And the concept here is you're running 2 different scripts. Step 1, you are running a process, which is like basically a collection of counters against the server that you want to migrate. The longer the better, ideally. The output of this becomes the input for step 2. And the output of step 2 is this recommendations HTML file, which you can see in this example that I was analyzing 2 databases, and it deemed the best fit for one of them was an S2, 50 DTUs, and the other one, it says 10 DTUs will be suffice. And it's something that I highly recommend as a starting point. So we've talked about additions, we've talked about how you would size it. What do you do once you are in Azure? Personally, the first step that I suggest is you create the logical SQL Server first. Now, technically you don't have to, but I like doing this because I like to know in my mind already where my database is going to go. So you can see on the left side, it's all the common things around subscription and resource groups. Server name would be the endpoint you would connect to and your location. And at the bottom, the administrator account and so forth. I will quickly show you how to create a database in my demo afterwards. But I just wanted to show you this and to talk about the limits on the right side. If you get anywhere near these limits in red, you will notice a performance of degradation and latency issues. So it's something to factor in at the early stages of your architectural designs. So what makes this product attractive? Well, first of all, you've got the 99.99% SLA agreement. That's built into the product itself. But there are other things as well. You've got the concept of automatic backups. So use the DBA, you need not worry about optimizing the full differential and transaction log backups. This means you can leverage the power of doing point-in-time restores with just literally clicks of a button. We've also got this concept of active geo-replication, where you can build secondary databases which can be in the same data center or in totally different data centers. Closely linked to this is a concept called failover groups, which I will talk about later on as well. And a very important tool set which is worth mentioning is ADS, Advanced Data Security. So you can see there's many attractive features available to you. Hopefully there are many DBAs here, and you'll definitely be thinking about backups. So I've got a slide on backups. As soon as you create a database, Microsoft initiates a full backup in the background, and then full backups are weekly. Differential backups are taken between every 12 and 24 hours, and log backups every 5 to 10 minutes. If you are not happy with the default retention rates, or for some compliance reasons you need it longer, all the way up to 10 years is possible if you enable long-term backup retention policy. It's just an option there for you. Failover groups. As I mentioned before, this is closely linked to active geo-replication, but think of failover groups as an abstraction layer that sits above this, and it allows you to manage many databases in a failover group. So you're handling databases at a scale. Now this is good because, as I just said, you can handle many databases within a failover group. It's very easy to set up and deploy. And the biggest thing is there's no more messing around with connection strings anymore. This is because we've got access to a read, write, and listen endpoint, as you can see at the bottom of this screen. This is typically what you would put in your connection strings. So it doesn't matter what server is your primary and secondary within the failover group relationship. That read, write endpoint will handle all that for you in terms of routing to your connection. Data migration techniques. I've got 4 main ones here. The first one I would probably say is what you should always do is go and get yourself the data migration assistant tool, which you can get from Microsoft. 3 key elements to this. You install, you assess, and then you can potentially migrate. Once you install, it's just a very common GUI interface, but the next phase is assessment is absolutely key, because you need to know that first of all your on-premises workload can migrate, or if you can't migrate, what do you need to change? And most likely it'll probably be code changes. And once you've made those relevant changes, you can then actually do a migration. If you don't want to use this tool to migrate, you don't have to. You could be a bit more manual if you like. That second option there is an inbuilt option within SQL Server Management Studio, where you literally right click, and then what will happen is it will use a backpack under the covers to move to the cloud. Or you can be even more manual and control it yourself by creating your own backpack. You take that backpack, you move it into your own Azure storage container, and then you usually import this backpack into an Azure SQL database. You'd obviously need to pick a logical SQL server to do this. Number 4 is probably the most advanced solution that I've personally set up. It's the idea of setting up replication. So the idea here is you've got this publisher and subscriber relationship, and once you've seen that there are no more replication changes to handle, you've drained all those changes out between your on-premises database and the Azure SQL database. Now that is the moment where you flip the switch to point your application to your new destination, being the cloud. And obviously the benefit of doing this is that you've got way less downtime compared to the other ones, but it is slightly more tricky to find out. Unfortunately, I didn't put a link to my blog post showing you the instructions how you set this up. If you go on my website and you just type in transactional replication, it will take you to a guide that I've done to help you set this up. Security. A big discussion you would probably have to have before you even move to the cloud would be firewall settings. Now these are required if you decide to go down the IP address rules. Now there are 2 ways you can create this. You can create IP address firewall rules scope to the server level or the database level. Best practice is to create them to the database level. If you decide to go down the database level route, you can only set this up via T-SQL, which is by a command called spset database firewall rule. And I've got a little demo that will show this. But I just want to make something clear here. Even though you've got server level firewall rules, it doesn't mean it's wrong. It's very rare to see this in production. Very likely you'll be using database level rules scoped to a database, and this will be even more true, especially if you're using failover groups. If you decide that you do not want to go down the IP route, well, you've got this concept of virtual networks called vNext. The key objective here is to isolate connectivity to your logical server from a given subnet. So if you just look at this basic diagram, you'll see this is very basic. Just to hammer the point, to give the point home, is here you can see I've got a virtual machine within a virtual network. Underneath that virtual network is a subnet. And what I will say on the logical SQL server is that I'm going to map in this virtual network so it can communicate with this logical SQL server. And you do that by just literally clicking on add existing virtual network, assuming you have one already. However, you are still relying on public endpoints. Enter private endpoints. The actual feature is called private link, and with this, ultimately what will happen is you are doing communication over private IPs now. If you go down this route, there is a lot of DNS work needed, so you probably have to sit with an Azure admin to set this up. And there are many companies that will probably want to do this. And if this doesn't just apply to Azure SQL databases, this is available in other services as well. I think I just want to make something clear here with the private endpoints and the DNS service endpoints. End of the day, they both have a similar concept, that they both isolate network traffic of the Azure backbone. However, with the vNext service endpoints, you are still relying on a public endpoint at the destination, for this example being the Azure SQL database itself. And this is true regardless of whether you're using express route or a site-to-site VPN. So you can remove this reliance on this endpoint by leveraging private link, where you effectively bring in your own private IP and you're connected to that private IP. So that's the big difference between the two. Okay, so there is absolutely no excuse to not set up AD authentication anymore. When I first started out with Azure SQL Database, I only could rely on SQL logins. Well, this is one of the first things you should be setting up. And it not only does it mean, it's obviously more secure than SQL authentication. You can do password rotation from a single place. You can enable MFA, multi-factor authentication. But as an administrator, I want to have these groups. I want to manage groups. I don't want to manage logins and users. And you're going to be asked to create managed identities as well. And you're going to have this set up in the background. So there's a lot of benefit to enabling AD authentication. Okay, so I'm just going to switch out of this and quickly show you the Azure portal. I'm just literally going to show you how easy it is to create and connect. So as you can see, I'm already at my favorite SQL server called Milky Way. And you click create, and this just kicks off a create database. You state your subscription, your resource group as you normally do. You give yourself a name. I don't want to use elastic pools. And under the compute and storage section is where you get to see all the different tiers. You've got the vCore model, you've got the general purpose, the hyperscale and business critical, which we mentioned about, whether you want provision or the serverless concept. Or if you want to go back to the D2 model, you can, basic, standard, and premium. So I'm happy with 10 D2s here. You click apply, you go to next, the networking section. The firewall rules are read-only now, so any changes you need to make to the firewall section, you'll have to do afterwards. And over here is what we've just discussed about the idea of using private endpoints. Additional settings is where you want to get your data from. You can have an empty database, you can take a sample database, or you can take a current database. Now this is great because this will go and find recent geo-replicated backups from any other database you've got. So it's a great way of, if you want to copy something. Correlation level, you can find whatever you desire. You can tag for billing purposes, what have you, if you desire. Then you literally just click review and create, and that will just churn off in the background. Once that's turned off, what you do, you normally, as admins, connect in through Management Studio. And because I haven't got Active Directory enabled here, I'm just going to use SQL Server authentication mode. And you will see that I'm coming in under the master database, and I'm going to query sys.firewall rules. Here, I've got a server level firewall rule called Arun local. Now this is okay because this is not production, this is just the playground area, and it's a quick way for me to be able to access everything here within my database list. Typically, what you will want to do as well is create database level firewall rules. So what you do is, once you've gone into the context of the database, you'll see I haven't got anything. You'll execute the command that you would have seen earlier on in my deck, the spset database firewall rule, where you literally pass in a name and your IP address start and end. Do a select statement again, and you'll see, look, so this IP address, obviously it's fake, 0.009, will have access to blobdb. If you don't want that anymore, you execute this command here, sp delete database firewall rule. So that's it really. I just want to show you how easy it is to create and log in by Management Studio. Let's move on to security. Now, the best feature with an Azure SQL database from a security perspective is ADS, Advanced Data Security. This, in my opinion, especially in production, should always be enabled. It does cost money. I'm not sure how much in US dollars, but I believe in British pound sterling it is 11. It gives you access to 3 features. You've got data discovery and classification. Now, this is a way to discover, label, and classify data, especially if it's sensitive. Can be extremely useful if you're doing GDPR-based exercises where you want to find, first name, last names, SSN numbers, credit card numbers. You can label it. You can then do vulnerability assessment scans. What better place to start fixing issues than with this tool, because this will flag risks that you currently have within your database estate. And what it will do, it will rank risks from high, medium, and low. And it's there for you to then, it's down to you to sort this out. An example of a high risk, it will actually flag a server level firewall rule as a high risk, which I think is a good thing because it will provoke you to go and have a look. Hey, do we really need this? Is that IP address really need access to everything on here? And it will also flag risks around, such as a low-level risk around logins and what sort of permissions are being assigned to it. And another great benefit of this, that you can schedule scans. So you can have this assessment tool kick out a scan every week, just as an example. So if anything has actually changed without you knowing, you've got a report to show you, oh, you've got a new risk. So, and that's something which I think is extremely powerful. And on the right side, if you don't think this is a great tool already, you definitely will with Advanced Threat Protection, a proactive monitoring service which is there to protect you. And that is why I've got a dedicated slide on this. Advanced Threat Detection protects you from so many things, from SQL injection patterns. It will look for out for attacks on there. It will trigger alerts if it deems it's seen access from unusual locations. This could be, if it doesn't recognize an IP address. Same sort of concept with logins and users in terms of unfamiliar principals, and it can also look out for brute force login attempts as well. You know, these sorts of things you can't really code yourself, so this is a great tool to leverage. Advanced threat detection is best experience if you've got auditing enabled, and that's why there is some cost to it to store the data. And you can see on the right side of this screen, that is actually an email that you get sent real time if it deems that there's an alert, you know, a threat. And it's just great, you know, it gives me a peace of mind, and I'm sure it will give everybody else a peace of mind as well. Let's move on to performance tuning. What is the ultimate bad combo? Well, this is what I call the ultimate bad combo. This is just an example on a DTU based database I got. I call this DTU exhaustion. You can just see a total flat line, 100% of my DTUs being utilized. You absolutely do not want this. This could be down to a few things. This could be down to you just got the wrong service level, wrong tier of compute size, or even worse, you've just got dodgy code. And what you don't want to do here is just keep scaling up and up and up and masking the issue. You need to make sure your code is optimal. So you're probably thinking, with the performance tuning mindset on, what do you do in monitoring? Me personally, there's two ways. You've got the Azure portal, and you can leverage DMVs in Azure SQL Database. But there are two key DMVs that I absolutely rely on. On the left side, you will see sys.dmdb resource stats. Now, this is a way just to see within the context of the database, the behaviors in terms of CPU and the data IO, in terms of averages and the maximum in percent. And the right side is database weight statistics, not server level, these are database level. Whilst this won't tell you what is causing an issue, this will give you an understanding what is going on within the context of the database in terms of an environmental context, which is something that I always want to know as well before I delve in deeper within a performance tuning exercise. So you've got your DMVs, but you've also got the Azure portal. This would be basically your single view to manage your resources, okay? You would probably base a lot of your basic work on this compute utilization graph, and you have the ability to add in many metrics. You've got basic metrics, and you've got a bit more niche metrics around temp DB and SQL Server process memory percent and so forth. And again, this is just painting a picture. You're not going to find out what the problem here is, but again, it's just to get your mind understanding, look, hey, I'm seeing D2 exhaustion here, but now it's time to delve in deeper. And to delve in deeper, this is where you start leveraging something like Query Performance Insight. This is where you find the actual query text, for example, the T-SQL statements. So if you have a look at this screenshot, you'll see all this again. This is within the Azure portal, and it's all color coded. So if there's a color here that interests you, for example, I want to see what that blue bar chart is. You would then navigate down to the bottom and look for the blue query ID. In this case, query ID 102. What you would do then is click on this query ID, and then it will present you the actual code behind it. Now that's what you exactly want. You have now found the code causing the resource consumption, the high resource consumption. But at the time of writing, you cannot get the execution plan. You will have to leverage classic ways of getting the execution plan, like Management Studio. Hopefully they will build this in one day, because I think it will just complete the whole picture. Automatic tuning. Now this is a proactive service that runs in the background. It can do three things. It can help you create indexes, it can drop indexes, and plan regression correction. This is plan stability. Now, what will happen, this is actually a pretty good feature, I should say, because what will happen is if you decide to let this feature go in and just do these sorts of activities, for example, let's create an index and you tell automatic tuning to do it, it actually goes through a verification process at the end and it will monitor it. And if it deems that actually a regression has occurred because of this create index, it will actually revert the change. Now, I'm not saying that you should switch this automatic tuning on. That is very much your own decision. But I have seen people who have not got a performance tuning background or haven't got a DBA background or even a development background, they enable this, which is fine. But me being me, for example, I tend not to enable this. I just wanted to show you that it's possible to leverage such a thing. What I do is I leverage the power of Query Store. Now, a lot of people who are watching this will probably know what Query Store is. And honestly, it's not that much different to Azure SQL Database. Here, you can see all your plan stability issues. You know, you've got your query IDs, and within the query IDs, you can see if you've got many plan IDs. From here, should you force or unforce? Now, this is the decision that you, as the performance tuner, will be making. What I will say is, when you create a database, it seems that a query store is on by default, which is great. And I suggest, and I know that this will be one of your main areas, one of your main tools within your performance tuning toolset. So don't forget, it is here in Azure SQL Database. I get asked a lot of questions. Hey, is SQL Trace available in Azure SQL Database? Well, no, it's not. Simply, it's not. The closest thing you can get is extended events. However, it is slightly different to on-premises extended events, which is quite natural in terms of you've got less actions and less events to work with. But I'm sure that gap would close. And there will be times you will probably want to leverage extended events. For example, you can see I wrote this code called Azure Monitor at the bottom. I highlighted the key difference here. You're actually creating an event session on database, whereas on the on-premises SQL Server, you don't do this. You do it on the server, right? For this example, I was trying to track real-time XML deadlock graph, and I was writing it to a ring buffer. 99 times out of 10, you would probably want to bind the output to Azure storage account. How do you do this? Well, if you followed this link on my blog, I actually go through a step-by-step process to do this. You might think it's quite complicated because you have to set up shared access signatures, database got credentials and secrets. Honestly, if I can do it, then I think anybody else out there can do it. And it's just a way of, persisting this data for you to query at a later stage. So yes, extended events, very important. Taking one thing step further within the portal, you've got this concept of Azure SQL Analytics. When I wrote this deck, it was currently in preview. And what it is it's a really nice way to visualize important metrics. For example, you can see from the screenshots here, you've got bar charts around database weight statistics, but you've also got charts about what's happening with query wait durations and things of that nature. But if you enable this feature, it will also tell you real-time SQL insights and real-time errors that pops up if things happen. If you want to enable this, you have to enable diagnostic settings on the database, which you can do through the portal. Just to keep clear what sort of options are available to you with this feature, I've mentioned these before, but these the screen provides you with a bit more detail. As I mentioned before, you've got the blocking, you've got the timeouts, and all the real-time errors and insights. But, I'm actually hoping that they extend this further forward as well, because it's got a great potential. DBCC CHECKDB, one of my favorite topics. We all know what DBCC CHECKDB is, the idea of running consistency checks. Now, if you look at this screenshot of my DTU percentage, this is actually me running CHECKDB because I got to a point where I was obsessed with it and I just wanted to make sure that there's no do. But it got me thinking. This is Microsoft's I/O subsystem. It's their hardware. Should I run this? Actually, it is Microsoft's responsibility. You can look at this as a good thing or a bad thing. I don't know. That's down to you. But I look at it as a good thing because it takes away another one of those physical administration tasks that I used to do a lot of. And it lets me concentrate on other areas like performance tuning. And Microsoft leverage all sorts of techniques, from automatic page repair to advanced concepts like I/O system, lost write detection, which is a way of, they use this way to track LSNs. But the question here is, you're probably thinking, well, what happens if there is corruption? Well, if that corruption is minimal, and if the corruption, and if Microsoft think that they can fix the corruption without it affecting you in terms of your SLA, your availability from a service point of view, and your data in terms of data loss, they'll just fix it. However, if there is a catastrophic issue, they have no choice but to contact you, liaise with you, and to lay out some plans on how to get back to the clean restore point. Now, just to put this into perspective, I've been working with Azure SQL Database for 4 years, hundreds of databases, and I have not yet once been contacted about corruption. And I'll be honest, at the time when I was running DBCC CHECKDB, I have never encountered corruption. You're probably wondering, because this is a technical debate by some out there, I have it with my fellow colleagues. If you decide that you actually want to run DBCC CHECKDB and automate it, that's fine. There are many ways you can do this, from concepts like Azure Logic apps to PowerShell scripts. And in the next 3 weeks, I'm going to have a blog post coming out soon where I have built Azure functions based on C#, where I have automated DBCC CHECKDB based on a timer trigger. So that's another way you can automate this piece of work. So you will see that working with Azure SQL Database, you're bringing your on-premises skills into the cloud, but yes, you are becoming kind of a cloud-based DBA as well. And I look at it as 4 key areas which you will have to master. You will have to master the concept of service tier and compute sizes, getting the right size, sizing your on-premises workload, and understanding the key differences from an architectural point of view as well. Security, you probably know by now how important it is. I'm not talking about just the features here, but also, do you know, should you be using vNext over IP addresses? Are you concerned about vNext? Should you be using private link? These are the sorts of discussions you should be having at design phase. If you decide to use failover groups, guess what? It's your responsibility to set this up and to actually test it. Testing is really important to see the behavior of your applications. And honestly, performance tuning is not going anywhere. You have to master this on premises, and it is even more important in the cloud. So that's it for me. Thank you for joining me. I'll open up for any questions, I believe.
Excellent. Thank you very much for that, Arun. Yeah, we've got some questions. Let me first go to the ones that just come in, so we can clear those ones down. The first question here from Rennie: what about the most advanced migration scenario, data sync? I'm not sure what that question really is, but so can you maybe labour a little bit on that point with regard to migrating using data sync?
Well, I personally, data sync I tend to believe is best if you need bi-directional communication between your on-premises SQL database and Azure SQL Database. I personally not seen it as a migration strategy, just more for sort of keeping databases in sync. I have set that up in the past. It needs a lot of agents, and it can be quite a laborious exercise to set up.
Okay. Next question: where can I pause Azure SQL DB? I only can find a way to pause Synapse.
No, yes. So You can't pause it. The closest thing you can do, as I mentioned in the slide deck, is use the concept of Azure SQL Database Serverless, where your compute will get paused by Microsoft based on an inactive period that you define.
Great stuff. So if you define that period, can you have any sort of intelligent definition, like if you have a window where you want it to pause, but if there is still activity, you can tell it to carry on? Is there any sort of intelligent thing like that, or is it a hard stop kind of scenario?
I don't believe there is any intelligence to it yet. It will literally track just activity, and it will resume again once you initiate something, whether that would be a system-based initiation or you logging in back into the database.
Okay, great. If I choose a lower tier, can I change up or even down, or even change to or from classic and vCore tiers?
Yes, you can, and that is another benefit which I probably should have made clear, so I do apologize. The beauty of this product is with a click of a button, you can scale up and down. You can cross from DTU into vCore. However, if you select hyperscale, you are stuck on hyperscale.
Right, okay. So I guess you really want to be careful before you do go to hyperscale then.
Yeah, I mean, I think if I remember correctly, it will give you a warning when you create it anyway.
Right.
Unless I changed that recently, but I did do that about 3 weeks ago.
Okay, great. Can I add integration services catalogs in Azure SQL, or is it a separate feature?
Integrations. Right. I believe you would probably need to go down Azure SQL VM route to install that. I don't think you can natively do that with Azure SQL Database.
Yeah. Okay. Cool.
So you need to leverage IaaS there.
Yeah. Yeah. If I want to run SQL agent jobs in Azure SQL DB, how would I do this?
Okay, so this can be quite. I kind of touched on it a little bit when I was talking about how you could automate CheckDB. In the past, I have built logic apps. You can run PowerShell. You can automate PowerShell in Azure, but I tend to use more Azure functions now to automate things. If I want to run stored procedures or actual ad hoc code,
yeah,
on a schedule, I actually use Azure functions.
Okay.
And to be honest, if you're in an enterprise, you can actually, for example, I'm not saying this is the best way of doing it, but if you're absolutely desperate, you can build, say you've got a Azure VM, and it's in a specific VNet, and you connect that VNet to Azure SQL Database. I've set up link servers where I have then set up SQL Server agent jobs on the VM, calling on the link server to do something, and that link server points to platform as a service. So you can concoct all sorts there.
Yeah, excellent. I also came across, I confess I hadn't really heard about it beforehand, but I saw people tweeting about it recently, Elastic Job Agents, which are currently in preview. So I did have a bit of a play there. Have you played around with those things yourself?
I believe, I believe that's for Elastic tools, is that correct?
That's right, yeah, Elastic Job Agents. Yeah. So that actually creates a SQL database when you go through the setup process for that.
Yeah, I believe that becomes like the control database, doesn't it? It holds all the metadata.
Yeah, that's right. Yeah.
Yeah.
But apparently, it's been in preview for a very, very long time.
It has. It has.
Okay, so you kind of touched upon availability, but so can I do always on availability groups and use readable replicas or something similar in Azure SQL DB?
Yeah, I mean, look, the big benefit of this product is, for example, if you select the premium tier or the business critical tier, you don't need to set up availability groups. It's doing all this in the background for you. And literally with a couple of clicks of a button, you can set up your secondary replicas somewhere totally different, in a totally different geographical location. So you don't specifically have to set this up like you would on premises. It's already Microsoft leveraged it in the background, but you would expose these other replicas through the Azure portal, if that makes sense.
Yeah, definitely. One thing that springs to my mind is, so on the sort of classic availability group deployment on premise, if you missize your replicas, you can run into all sorts of performance problems. Can you have smaller sized replicas in the cloud for Azure SQL DB?
I can't remember. I mean, I've got one set up now, which I could probably check, but I don't want to take too much time. But if at the minimum, I would keep it the same. But it's a good question. It's kind of dangerous ground, isn't it, if you go too low?
Yeah, definitely. Somebody's made a comment, so René's made a comment, he's mentioned that sys only works on managed instance. So you mentioned it works obviously within an IaaS VM installation of SQL. So is he correct in saying that sys is supported on managed instance?
What's sys? I don't understand.
Sorry,
sys.
SSIS, sorry.
Yeah, but also it's infrastructure as a service it's supported on. It's just literally your own VM, and you build your SSIS, Azure SSIS runtime there.
But I mean, as your PaaS, as your managed instance is PaaS, though, isn't it? So I think René's suggesting that does support SSIS.
Oh yeah, no, that one probably will, most likely, correct. That one, if you remember the diagram I had at the start, kind of sits in between both of them, the managed instance. But it does, if I remember correctly, it will host an SSIS catalog. They're executed on a what's it called? A managed Azure SSIS integration runtime in when you're using Azure Data Factory.
Great stuff. Okay. What exactly constitutes a DTU? So is it possible to understand how much DTU I'm actually consuming from a given query at a given point in time?
So obviously this concept of database transaction unit, this blended measure of CPU and so forth, memory and so forth. The way for you to kind of track that is it's through the Azure portal by looking at the metrics, and if you pull in the DTU metrics, you can actually be quite granular.
Okay, great. Okay, so when you create an Azure SQL DB, you need to specify or create a SQL instance to go with it. Should I have one instance for every SQL DB that I create?
Yeah.
Or would I have many databases on one instance? So would you have a one-to-one relationship with your instance and database, or many databases?
There is no reason for you. It's down to you and your architecture and your design. There's no reason to have a one-to-one relationship. It kind of depends what your aim here is. Don't forget that I said that the limit is up to 5,000. So if you're nowhere near that limit, you should be fine from a performance point of view.
Right. Okay. So I'm guessing that the other considerations you might have maybe would be geographic placement of the database and instance. And there's one other that sprung to my mind that security boundaries. I guess, are those some things you'd consider, would it, to firing up a dedicated instance?
Do you mean in terms of?
So if you had, let's say you had an application that was using a SQL DB that had sensitive data, I'm guessing you'd want to have a dedicated instance for that to have its own.
Oh yeah, I understand. Yeah, I mean, if you've got really sensitive stuff, you probably want to lock that away, and then you're going to have to probably leverage the private link and lock down all your IP addresses. So there's many moving parts to that sort of solution.
Yeah. does the concept of logins and database users still exist in SQL DB?
Yes, they do, but best practice is to use contained users, if you know the difference between the two.
Right, okay.
And as I said before, it's really important to use contained users, the contained user model in failover group strategies, because you want to take the users with you.
Yeah. Can I save any money if I provide my own SQL licenses?
I would probably say you can. I can't remember how much by or what the actual.
Okay, I guess that's one for people to look up the docs, don't?
Yeah.
Because I guess you're paying for the DTU, so
You pay for the you technically don't pay for that logical server, do you? You pay for the compute. I don't know.
Yeah.
Off the top of my head.
Ditto. There wasn't. So classic one. I'm sure you've been asked this one many times before. Can I perform a manual backup on SQL Azure DB or Azure SQL DB and restore those to on-premises?
Unfortunately, no. The only one you can do that with is managed instances, where you can natively support backup commands.
All right. Okay. Cool. Does SMS fully support Azure SQL DB?
Absolutely. I've been using it for years. You probably need to use the latest ones. I will say that. Minimum 17 plus, version 17 plus minimum.
Okay.
Because that will, I think they made some optimizations around the Azure AD authentication with that version onwards.
One thing I've noticed, I've not done an awful lot of Azure SQL DB, but one thing I've kind of noticed with SSMS is that if you're a big fan of GUIs and dialog boxes, it doesn't seem to provide an awful lot of that kind of integration. So the one example I'm thinking of is if you're creating or want to create a database user, I think it just creates a script in your window, I think, but I don't think you'd get your classic dialog box.
No, you're right. Yeah. No, it is watered down, but it is fully supported in terms of, it's, you can manage.
I guess that's one reason to all of us DBAs have our own sort of little libraries of scripts, don't we? So I guess that's one reason to sort of bring your own to the table.
Yeah, no, absolutely. You can leverage not just Management Studio for your admin. You can use Azure PowerShell or Azure CLI.
Cool. And I think we're going to make this one the last question. So what locking models does Azure SQL DB support, and what does it default to? Does it also support in-memory OLTP and column store?
Yes, so the transaction isolation levels are all the same. You've got your pessimistic ones and your optimistic ones. By default, I believe it's recommitted snapshot isolation, which is different. Obviously, I think classic SQL Server is recommitted.
Yeah.
And what was the other part of the question about in-memory OLTP? I believe last time I checked is only available in Premium Edition. And column store is S3 onwards. But that's going back last month because it's at the top of my head.
Perfect. All right, well that's been brilliant. I've learned quite a lot today, so thank you very much for that.
No problem. Thank you.